All right. So this is a unique motion problem because we're dealing with a stream. As you know, when you are rowing downstream, you go what? Faster, and you row upstream, slower. Because you're dealing with what is that? It's a current, right? So that's one of the things we're dealing with in this problem. So we have a camper that rowed 24 kilometers downstream and then returned the same distance upstream in twice the time of the downstream trip. Okay? If the camper can paddle 6 kilometers per hour in still water, then find the rate of the current. So we're going to set up our chart with rate, time, and distance again. So this is rate, this is time, and this is distance. So I'm going to label this one downstream and this one up for upstream. Okay, we know our distance. So that's 24. So I'm going to go ahead and fill in my chart here under the distance. Okay, and we know that he is paddling, or he or she is paddling 6 kilometers per hour in still water. But if we're going downstream, that current, what does that do? It speeds it up by that amount. So I'm going to say x, 6 plus x. And x is going to be our current. Now, when we return going upstream, if it's 6 plus x going down, what's going to be going up? 6 minus x. Okay? So now we can find our time by taking the distance divided by the time, because we know that time equals d over r. Okay, the next thing that we really need to look at on this is it says return the same distance in twice the time of the downstream trip. So basically, they are saying it's 2 times downstream equals upstream, correct? So I have my downstream time, I have my upstream time. So I'm going to write this out as 2 times 24 over x, 6 minus x. And then the other one is, this should be 6 plus x. And the other one is 24 over 6 minus x. Oops, what did I just do? Okay. Yeah. All right, so here I am. I'm going to multiply that out. So that's going to be 48 over 6 plus x equals 24 over 6 minus x. Yeah, they don't have the same denominator, but this one's set up easier because we only have 2 terms to deal with. So I can cross multiply. So I'm going to take 48 times that, so it's going to be 48 times 6 minus x and 24 times 6 plus x. All right, so 48 times 6, I think it's 288 minus 48x, and then this is 144 plus 24x. How do I solve for x? So I can subtract 144 from both sides. Yep. Okay, add 48x to both sides. So now I have 144 equals 72x. If I divide both sides by 72, I get x is 2, and once again, remember, x is our current. So our label for this is going to be kilometers per hour. Okay, Will travels to work by car, in 1 hour less than it takes to make the trip by bus. The average speed when traveling by car is 64 miles per hour, and when traveling by bus, the average speed is 48 miles per hour. Find the distance between the two cities. So, we are going to start off with our table. We always start off with tables on these problems. Motion, it'll be speed or current. So if you see speed or current, you're going to need a table. Okay? So, yep, rate, time, and distance. And then we're going to talk about car versus bus on this one. Okay? So the rate of the car was 64. And the rate of the bus was 48. Do we know the distance on this one? No, so we're going to put an X there. So we know our time is going to be X over 64. And our time over here is X over 48. But there's one other bit of information that we got in the first line, and it says, Will travels to work by car in 1 hour less than it takes to make the trip by bus. So I need to somehow make my car time equal my bus time. So that's just one equation, but I'm going to take that 1 hour from what? Which one's longer? The bus time. So I need to make that bus side equal my car side by taking a 1 hour away from it. Okay? So here I have my general equation. Now I'm going to replace it with my t's from my table. Yep, x over 64 equals x over 48 minus 1. All right, so if I'm going to multiply these out by a common denominator, this one's missing a 48. So I'm going to multiply top and bottom by 48 here. This one's missing a 64. And this one's missing a 64 and a 48, if I'm going to have the same denominator. Okay, so 64 times 48. Is a big number. For some reason, my calculator is not cooperating with me. Okay. You probably could have. Yeah, there's probably a much smaller number.
64 times 3 and 48 times 4.
Okay, yep, you could have done that too. Okay, so that's good. 64 times 3 and 48 times 2. Right? Is that what you said? Or the other way around? So 48x equals 64x minus, this is a minus, 3072. Now notice they all have the same denominator now. They all have 3072 if I were to multiply this out, right? 3072. Okay, how do I get rid of denominators in an equation? Multiply by the denominator and it cancels them all out. So basically, I'm telling you guys, now at this point, you can get rid of your denominator. So I'm left with this. How do I solve for x? Okay, so if I subtract 64x from both sides, is 16x, and it's negative, and negative 3072. Take 3072 divided by 16, you get 192. So my distance is 192 kilometers or miles. All right, Sophia made a round trip between two cities that are 450 miles apart On the return trip, she increased her average rate by 5, and she made the trip in 1 hour less time. All right, so we need R, T, and D again. We need to and from. And we know D is 450 miles. What don't we know? We know distance. We just don't know rate.
We don't know the rate, but we know.
Okay, so I'm going to use X for my rate. So on the way, it took her X miles per hour. On the way back, she increased her rate by 5. So how do I write that? X plus 5. So to set this up, this is going to be 450 divided by X. And this one's going to be 450 divided by X plus 5.
Wouldn't that also be -1?
Right, and I'm not there yet, but yes. So we have this -1 somehow. So what they said is
Attention seniors, please.
our two equal our from, and it said they made the return trip in 1 hour less than the 2 time. So I'm going to take 2 minus 1. So this will be 450 over X minus 1 equals 450 over X plus 5. Okay? So now you guys got to find common denominators. There's a lot to this one because it ends up being a quadratic. But at least I hope you got it set up.